The roster method and the set builder method are both ways of expressing sets of elements. Let us try and understand when each one can be used, when one of these cannot be used, and more importantly, when both can be used but one may be more appropriate than the other. So let's start with the roster method. The roster method is used to express a verbal description of a set of elements into an actual list of the elements. That's the key term there. We need to generate an actual list. To associate the roster method with something that you know so that you can remember, think of the class roster. What is a class roster? It is an actual list of the names of all students that have signed up for the class. So that's our idea, providing an actual list of the elements in our set. Let's look at a few examples. In the first example, we need the set of natural numbers between 5 and 9. Now, in the roster method, the elements are enclosed within curly brackets. So let's start with opening up a curly bracket. What are the natural numbers between 5 and 9? Well, they are 6, 7, and 8. So that's our set. We have written out the set of natural numbers between 5 and 9. Now what's with the 5 and the 9? What if in my set I actually wanted to include those two elements? Well, if we want to include the two elements, then we must redefine our set as the set of natural numbers between 5 and 9 inclusive. That word inclusive will then tell us we need to include the numbers 5 and 9. So this set here will be written as starting with 5, so 5, 6, 7, 8, and 9. So note that the word inclusive here told us the number 5 had to belong, so we included it here. The number 9 had to belong also, so we included it here. Let's look at another example. What is the set of whole numbers that are less than 4? Well, we need the set of whole numbers. Whole numbers start at 0, so the smallest number we can list is a 0. So we start with the 0, 1, 2. How far do we go? Our numbers have to be less than 4. So we are going to stop at the number 3 and close our curly bracket. Next example, we need the set of integers between -2 and 3. Well, now you get the idea. Because we do not have the word inclusive in there, the number -2 cannot belong. So in our listing of the integers, we have to start at -1. We include the 0, we include the +1, we include the 2, we cannot include the integer 3. So we close our curly bracket here. Next example, the set of integers that are greater than 9. I included this example so you would understand that the roster method can be used to represent finite sets like this, where you can list out all the elements, but it can also be used to represent sets of numbers that are countably infinite. So how do we write numbers that are greater than 9? We start with the number 10, and there is 11, and there is 12, 13, 14, and so on. How far do we go? Well, we need to put in enough numbers so that our reader knows the pattern of the numbers to follow. So we say 10, 11, 12. Our readers can figure 13, 14, 15, and so on will come next. So we put 3 dots. I like to think of them as indicating and so on. We are done. Now in the next example, I have written up set of real numbers between -2 and 3. You might be tempted to say, well, I can start with the -1, but I would immediately tell you, stop. I have said sets of real numbers between -2 and -1. There are real numbers that you haven't listed. There is -1.9, -1.8, and so on. Between the -1.9 and the -1.8, there is -1.81, -1.82, and so on. Well, that's a problem. the set of real numbers is not a set that we can list. So the key thing here was understanding that the problem asked us for set of real numbers, and we can never generate an exhaustive list of the set of real numbers. So this set cannot be written using the roster method. So let's write out here, cannot be written, or just say cannot do it. Now I have included another example here just so you understand that the sets do not have to be sets of numbers, they need to be sets of elements. So in this last example, I have put in the set of months in the year beginning with the letter M. So now we need months, so we start January, February, of course, will not be included. The first month that starts with the letter M is March, so we will include March. April cannot be included, we will include May. And no other month of the year starts with the letter M. So this is our exhaustive list, and we are done. So an important note for us, since the roster method requires generating a list, it is essential that the elements be discrete so that you can list them. So let's go over this. Which of the following sets of numbers can be expressed using the roster method? Can we write out the set of natural numbers using the roster method? Yeah, sure. Natural numbers can be listed. We start at 1 and we keep going in discrete increments because natural numbers are the numbers we use for counting. So 1, 2, 3 and so on. How about whole numbers? Well, that's the set of natural numbers plus the 0. So yes, these are discrete also and we can list them. So the set of whole numbers can be written using the roster method. How about the set of integers? Absolutely. It is an expanded set from here. It brings in the -1, -2, -3 and so on, but still moves in discrete increments. So yes, the set of integers can be written using the roster method. How about the set of real numbers? Well, we saw in our example, the set of real numbers are on a continuum. They are continuous. We cannot list real numbers. Any two real numbers that we list, there is an infinite number of real numbers that lies between them. So the set of real numbers cannot be written using the roster method. What about the set of rational numbers and the set of irrational numbers? Well, I think that this is something you should think about. Do you think they can be expressed using the roster method? Why or why not?